In this circuit, there's a switch here that changes from connecting this resistor to point A at times t less than 0 to connecting the resistor to point B at times t greater than 0. We want to determine what this voltage is across the 6 ohm resistor as a function of time, sketch that, and write it mathematically in terms of step functions and constant values. So, for t less than 0, the switch is connected here at A. I have a 2-volt source, this 6 ohm resistor, and this 6 ohm resistor, and V at t less than 0 is across this 6 ohm resistor. This constitutes a voltage divider. I have 2 volts here. 6 over 6 plus 6 is 1/2, so this is going to be half of 2 volts, or 1 volt. Now, for t greater than 0, the switch is connected at point B here. So I have my 6 ohm resistor again. This is still V of t, but now at greater than 0. This is in parallel with a 3 ohm resistor, which is also in parallel with a 3 amp source. So if I combine these two resistors, the equivalent resistance is 6 times 3 over 6 plus 3, which is 2 ohms. So this voltage, V of t greater than 0, is 3 amps times 2 ohms, which is 6 volts. So sketching this, if this is time, this is V of t. At t less than 0, we're at 1 volt. At t greater than 0, we've jumped up to 6 volts. And there's our sketch. The voltage isn't really defined at t equals 0. To write this in terms of unit step functions, I can do a couple of different things. I can say I have 1 volt here for all time, and then at t equals 0, I add 5 more volts to that. So I can write V of t as 1 volt plus 5 times U0 of t. This is 0 for t less than 0, and it's 1 for t greater than 0. So this function is 1 for t less than 0 and 6 for t greater than 0, which is just what I want. That's not the only thing I can do, though. I could also say that this looks like a unit step function that starts at minus infinity and goes up to 0. So this green line here would be U0 of minus t. Then, at this point, I could add 6 volts when this guy goes down to being 0. So this section here would be 6 U0 of t. If I add those together, that's a perfectly legitimate version of V of t as well.